Hi guys, welcome back to the channel. In this video we are going to solve an example problem. So statement is draw the circuit diagram for this counter state diagram given. So the question itself given the state diagram. From the state diagram we are going to draw the circuit or the counter we are going to draw. And we need to draw the ripple asynchronous counter. It is also mentioned in the question. So let's see how to do that. So basically to design any asynchronous counter we are going to follow some steps. First step is to find number of flip-flops. Next step is to draw the state diagram. But by question itself we know the state diagram. So first step is to find the number of flip-flops. So we need to assume or we need to find out the number of flip-flops to be used, and we need to have an idea which flip-flop to be used. That is our wish. We can use any of the flip-flop we want. So this step is to find the number of flip-flops. So if you observe the sequence that they have given, that is starting with the 111. So 11, that is 111 means what? That is in decimal 7, and 110 6, and 101 means 5, and 110 means 4, and 011 means 3. So basically the sequence is 7 6 5 4 3, and again it continues 7 6 5 4 3, like that the sequence continues. So in this sequence we have the highest number as 7 means in decimal. So 7 means what? 111. So 111 means we are storing 3 digits. So 3 means 3-bit counter. So total we are going to use 3 flip-flops. Or we can simply use this formula. The capital N is equals to 8 means there are total 8 states in this, including unused states. Unused states means not given in the sequence also. So total, if you compare the formula, that is capital N less than equal to 2 power n. So N is equals to 8. So we can also observe the small n is equals to 3. And I took in this flip-flop as JK flip-flop. You can use T flip-flop also. Now we are going to form the truth table with the help of the outputs. So we are using 3 flip-flops, we are going to have 3 outputs, that is Q2, Q1, Q0. So Q2 from the one of the flip-flop, Q2 and Q1, Q0 are 3 outputs from the one of the flip-flops, one flip-flops. And what is this preset logic? So preset logic is nothing but whenever you see the last one, that is 3, then the next step of 3 would be again we are going to have the preset logic. So preset means again all the outputs Q2, Q1, Q0 would be presetted to 111. That is the main logic of preset means. So if you observe, all the first 5 cases are highlighted with the preset logic as 1, and the last remaining 3 cases are 0 because those are to be resetted. Those are invalid states or unused states, we can say, in the counter. For the expression of the preset logic we are going to use the K-map. So as we are having 3 variables, that is Q2, Q1, Q0, I am going to use 3 variable K-map. So if you observe Y, we are having the minterms in the position 3, 4, 5, 6, 7. Or we can simply say the preset logic Y would be present in the only sequence of the counter. Other than the sequence of counter, we will not going to place the variables or the ones or minterms in the K-map. So we can have the 2 groups, 3 and 7 as one group, and 4, 5, 7, 6 as one group. So the output expression Y is Q2 plus Q1, Q0. Now we have obtained the preset logic, that is Y is equals to Q2 plus Q1 Q0 for this counter. So as I decided to use the JK flip-flop, so we are going to use the 3 JK flip-flops. So all the J0, K0, J1, K1, J2, K2 are connected to the input line 1, and all the clock pulses are triggered with the asynchronous because first clock is for the first flip-flop directly applied. For the second flip-flop is output bar, that is Q0 bar is clocked to the next flip-flop because as this is the down counter starting from 7, so that is the reason I took Q0 bar as clocked to the next flip-flop. And if you see for the third flip-flop, I took Q1 bar because this is the down counter. If you want more details about the down counter, I covered already videos in this, check out the playlist. And I am also going to give that video in the description box, please check it out. Or if you know that, so simply connect all the logic that we have obtained the preset logic, connect all the logic, that is Q2 plus Q1 plus Q0, Q2 plus Q1 Q0, connect that preset logic to the flip-flops, preset of the flip-flops. For that we need to have AND gate and OR gate, just join them like that. I hope you understood this video. Thanks for watching up to now.